let's dive right into it. You've seen many of the big technological shifts over the past decades, right? From the internet, mobile, social media, the cloud. Can you place AI in the context of these waves?
Yeah, so this is a big one. This is a really big one. So there's this great book I'll recommend right off the bat called Rise of the Machines by Thomas Reid. And he goes back and he reconstructs the very beginning of the computer industry, the sort of computer revolution back in the 1930s, 1940s. And it turns out back in the 30s and 40s, they actually had a big argument at that time of whether computers should be built the way that we understand them today, which is what so-called von Neumann machines. Basically very fast, calculating machines, that are very good at doing math at high speed, but aren't very good at kind of dealing with people or dealing with the real world, or whether computers should be built basically modeled on the human brain. And they actually had enough neuroscience at that time where they understood the basic neuron structure of the brain. The first paper on neural networks actually came out in 1943, 81 years ago now. And there were, figures like, Alan Turing and John von Neumann and others, who argued, that basically that would be a superior architecture. And then basically what happened was, right, the computer industry kind of forked, and 99% of it, was dedicated to building out computers the way that we've had them for the last 80 years. And then there was always this kind of rump, academic movement, which was for to kind of build out neural networks. And that proceeded decade after decade after decade. And frankly, if you talk to people in that field, there wasn't much to show for it for a very long time.
It takes a lot of conviction to really persist there.
So there were people would get their PhDs in artificial intelligence. They would be born, they would get their PhDs, they would spend their entire careers researching it, and they would die before the field worked, right? So this is like a high level commitment. When I was in college in the late 80s, there had been actually an AI sort of boom bust cycle. In the 80s around so-called expert systems. The people thought we were very close to like automated like medical diagnosis, all these things. And it didn't work. The technology wasn't ready yet. And so by the time I got to college in 89, like the field had been discredited. And so you would meet these, sort of sad figures, who were sort of toiling away, kind of wasting their lives. And then of course it turns out they were right. But it took us, and how long did it take to figure out they were right? Really, it took probably 70 years to figure out they were right, because they started, turning out to be really right starting in around 2012, 2013, which is when the famous ImageNet test happened, and then it sort of proved that computers could recognize objects and images better than people. And then that led to the creation of the self-driving car, which is now really working really well. And then that led to what became like increasingly good voice recognition, voice synthesis, in the mid 2010s, and then the Transformer paper in 2017, and then obviously ChatGPT and Midjourney and Runway and all these things, and here we are. And so the way I think about this is like an overnight revolution that's been like 80 years in the making, right? And so it turns out it's incredible, because it turns out we have this incredibly rich, kind of history of 80 years of ideas now that turn out to work, that are now going to get used in all kinds of ways.
Well, how do you see it unfolding now? Is the internet a good analogy if we're trying to look around the corner?
Yes, I think it's more just I think the internet is not actually as good of an analogy, because the internet was sort of taking existing computers and using them to kind of stitch together networks. I think this analogy is probably more to like the microprocessor or to the computer itself. So the way at our firm, the way that we think about AI systems is they're new kinds of computers. And the way we describe it is kind of traditional computers, or so-called deterministic computers, which is they give you the same answer every time. They're kind of very very literal in what they do. And if they ever if you ever give them the same input twice and you get two different results, it's because something has gone very badly wrong, and it's probably your fault as the programmer. AI systems, we view them as computers also, but probabilistic computers. You give them the same input twice, they give you two different outputs, which is amazing, for those of us taught, it's kind of the old model. And then they do this incredible, kind of thing, which is, they have different terms, but, they hallucinate, right? They like, people describe to me, it's like, AI skeptics will say things like, well, AI, is not useful because like when it doesn't know the answer, it just makes something up. And I'm like, well, have you met people? That's precisely what my 9-year-old does. Very interesting, right? And then, as we just saw with Runways, with these spectacular videos, there's this like fine line between hallucination and creation. So we have literally computers now that can create.
So it could be a feature or a
can actually create art. And so we basically have sort of another bite of the apple, right? The sort of magic apple. We have all the traditional computers, and now we have this new kind of computer. And then we have this, and then of course a big part of the story is the massive payoff right? Why does AI work today? Part of it is the experts kind of got the algorithms to be really good. But a big part of it is Moore's law actually provided the compute power, and it just turns out, right, you just need a lot of compute power. And then the internet provided all the data.
Yes.
Right. And so why do computers do a better job now? AI does a better job recognizing cats in photos. It's because the internet is filled of photos of cats.
Yeah, we take these scaling laws for granted now.
Yes.
But that was not obvious.
You could not 20 years ago, 30 years ago when I was in school, like even if you had the right algorithms, you could have never made these systems work. And all of a sudden now they work. And of course now the pace of change is just absolutely extraordinary. I mean, I see things every week now that just put my jaw on the floor. So I think we're in for years of just incredible creativity.
I mean, you have a unique vantage point at A16Z, seeing many different industries, right? I'd be curious what you think about the impact that AI is going to have in a variety of different domains, whichever ones you want to talk about, but I'd be curious about AI in biotech, or AI in finance, or AI in defense.
Yeah, so a couple things. So one is that we think it's going to be transformative in actually every single one of those sectors, and we're investing across all of those. We can talk about each of those. So I think it's going to be a really big deal in all of those. I think there's a really good chance that it really reinvents almost every product category that we think we understand today. And again, just take Runway as an example. Like, are people in the future really going to be doing video editing or photo editing, like using like Photoshop or Final Cut Pro or these things, or are they going to? Or are you going to be talking to the computer and the computer does the image generation editing? And so I think there's these huge industries where people kind of assume things work a certain way, where they're going to work very different. And of course that means it's going to be prime time for startups, right? That have the huge advantage of being able to to start from scratch. So yeah, no, we think this is going to be a really big deal. In the tech industry, this classic dynamic is playing out where every incumbent tech company is adding AI to their product, right? And then we have startups starting in every conceivable category from scratch. The metaphor that we use to kind of justify, because we go to our investors and say we're going to invest in all these AI startups, what we say is like, look, like if you have an existing product and you add AI to it, it's a little bit like adding flour into a cake, like after the cake's already been baked, like it doesn't work well. If there's a really transformative technology, you have to get the flour into the recipe from the very beginning. You have to build from scratch, knowing you have the new capability. And by the way, there's a bunch of companies. The sort of later stage startups are like halfway in the middle. We have this phenomenon we call bullet point number 6, or we'll get a sort of a 5-year-old company or whatever will come in and pitch, and they'll have their product slide, and it'll have the 5 kind of things their product does. Then it'll have bullet point number 6 is, oh, it also does AI, right? And it's always bullet point number 6 because of course they added it after the fact, right? They couldn't quite, the smart ones go in and redo the slide. And so, there's a lot of adaptation happening. Now, look, in the mobile to web, in the web to mobile wave, a lot of the big actually incumbent companies like Google and Facebook actually did just fine, right? And so it certainly may be the case that a bunch of incumbent companies actually adapted this just fine. I think it's going to be challenging. It's going to be a lot of work to do that because this is such a different way of operating. I tend to think that startups have a really great run here, but it's going to be a real fight, kind of in the industry, and we'll see. Yeah.
You pay a lot of attention to biotech,
yeah.
Right? What does this look like? I understand it for software products, but what do you think the role of AI will be in biology?
Yeah, so look, so the big thing in biotech biology is sort of that we've always had this concept of sort of drug discovery, which is this kind of amazing term, and basically, the way that sort of the modern world of kind of drugs treatments, has emerged is you sort of have, basically a lot of scientists basically trying lots of different compounds and kind of seeing what works. So you're literally kind of discovering what works. The sort of overall giant transition that field wants to go through is to go from discovery to engineering, right? So where you're actually, designing things from scratch, including literally designing new drugs from scratch. And we're starting to see examples of that. The mRNA platform that was the basis of the COVID vaccine, is a good example of that. Moderna had it was a very interesting. Moderna and Pfizer are the two companies that had the first COVID vaccines with similar technology. Moderna had the first COVID vaccine 2 days after they were emailed the genome of the COVID virus from China, like in a Word document, which is first of all like a fairly amazing thing because it's like spell check is pretty aggressive in Microsoft Word, and like you certainly hope that like it didn't screw things up, but it turns out it didn't. It was fine. But then like literally they had that vaccine 2 days. They had the COVID vaccine in January of 2020, and then the rest of it was just testing and validation. And that was the consequence of mRNA being a national engineering platform for biotech. And so the minute you have an engineering platform, you can bring AI to bear.
Do you think we have enough data in biology today
So it's a real challenge. It's a real challenge, and I would say it's a real challenge in particular because access, what you really want, like if you wanted the perfect biotech industry, what you would want is you would want to basically get everybody's health data, pool it all together. You'd want to get everybody's genome data, pool it all together. That in the U.S. that would all be completely illegal. You would never be allowed to do that. You would go straight to jail. Interestingly, in China, that's actually just fine. So it is actually this very interesting opportunity for societies like China to maybe leapfrog us on that point. So yeah, there are big challenges on that, but the payoff is also going to be very big, and so I think there's going to be a lot of positive pressure to figure out at least how to get enough data to be able to do the work.
Yeah. Speaking of China, how do you think AI will shape geopolitics or defense or some of these spaces?
Yeah. So this is an area where actually the sort of theoreticians in defense were actually ahead. They were on this several years back. So right around the mid-2010s, there was actually a sort of major change of military doctrine in both the U.S. and China. So in the U.S., the Department of Defense has a thing called offsets, and it basically an offset is like a new technology that will fundamentally change how wars are fought. And they declared that AI and autonomy in combination were what they call the third offset. And it's a big deal because like the first offset was nuclear weapons, the second offset was what they call maneuver warfare, and then the third offset is AI. And then China similarly has been very public.
Actually, what is maneuver warfare?
Maneuver warfare is sort of like small unit tactics, precision-guided weapons, sort of specific applications of force as compared to just like launch the nukes or like launch the bombers. And so maneuver warfare was like a consequence of advances in like communication technology. GPS was a big part of maneuver warfare. But AI is the big one, and so anyway, so the U.S. kind of forecasted that, and the Defense Department, and look, we have like the Predator, we have the Predator drones, that fly autonomously that have played a big role in counterterrorism. So that started to happen about a decade ago, and then China similarly embarked on a major, and they've been very public about this, kind of a major rebuild of all of their systems, based on AI. And
a decade ago is pretty early for this shift, given that the excitement around AI now. What triggered that?
Oh, I think it was basically they started. Well, one is they self-driving cars started to work. The original DARPA grand challenge for self-driving cars was like in 2005, and then so you started to see those basic systems started to work, and then you started, obviously autopilots on airplanes started to get really good, and they started thinking about taking the pilot out of the airplane. And if you take the pilot out of the airplane, all of a sudden you can build very different kinds of aircraft that maybe are like much more maneuverable, much faster, because they don't need to keep a pilot alive. And so these kinds of things, and then they keep people safe, right? And so those changes started. And then of course what's really accelerated all this thinking in the national security world is specifically the battlefield in Ukraine. Where it's like this, and start by saying like it's an incredible tragedy that this is even happening. But what's happening on the Ukrainian battlefield is shaping a lot of thinking around national security.
What is happening?
What is happening? Well, it's like 20th century versus 21st century. It's like a cyberpunk movie. It's fairly amazing. Which is the Red Army, the Russian military basically is driving tanks down. And the Ukrainians are responding with, first person, basically literally professional video game players piloting in VR, piloting autonomous drones, and then coming in on top of the plane and blowing up and cooking it on the inside. These shoulder mounted, weapons like javelins that again are kind of, they call them fly by wire. They sort of, they sense where the thing is. So there's a tank and you have a javelin, you sort of wave the javelin in the direction of the tank, you fire it, and it automatically homes in on the tank and then drops down through the hatch. And so, the Russians have taken devastating losses, as a consequence of this. And there's always, for the Russians, there's always a guy in the tank. For the Ukrainians, there's no guy on the drone. So there's an asymmetry to it. And so, Ukraine has punched way above the weight that all of the planners expected when this whole thing first started, because they've been very aggressivly innovating in the field, for how this stuff works. And then, of course, again, the other tragedy playing out, but similar kinds of developments are going to happen in the Middle East now. And so, we get these amazing asymmetries. And so the Houthis, for example, are firing these, I think they're Iranian drones, they cost, thousands of dollars. And we'll literally, U.S. military will use like a $20 million Tomahawk missile, right, to like take down a $10,000 drone, right? And so, you have these like momentary, it's like slippage in time, right? These things shouldn't exist in the same era. And so if you talk to people in the U.S. military, they're like, okay, now we need to basically reinvent the whole thing. Yeah. Like the way that we field everything from aircraft to submarines, like all these things is just going to completely change. War in the future is going to look totally different.
Is the battlefield itself the place where this will have the biggest impact, or do you expect it to shape policy or deterrence or other aspects of geopolitics?
Well, it changes a lot. I mean, so the sort of most advanced version of the thinking, I think, is basically defense historically, like sort of warfare has been an issue sort of mass and sort of number of men, amount of material, right? So how many soldiers do you have, and then like how many tanks do you have? Sort of, as Napoleon, I think, once said, God is on the side of the big battalions, right? And so it's like just like mass and force. And arguably, if you project this forward enough, what you kind of see a picture emerging is actually in the future successfully based on who has the best technology and the most money, right? And there's some connection between the best technology and the most money, because if you have the most money, you can either develop the best technology or buy the most technology. And so it sort of changes the and by the way, it means like if you want to then be the strongest military force, you then want to be the strongest economy with the most advanced technology. It means it's like really strategically important for your country to actually win in technology, which is something that's sort of hotly controversial these days. And so like that that matters a lot. Will you even have human soldiers at risk in the field or in planes or in submarines in 20 years? Like maybe, but I think probably not.
What does it take to win in this technology?
Yeah, so this is a very interesting. So this is sort of a very interesting topic right now for kind of U.S. politics. Which is like, so I have these. Technology has become a very politically loaded topic over the last decade for a bunch of reasons. And so I've been at our firm. We're much more engaged now in politics than we used to be, and I've been spending a lot more time in D.C. than I used to. And I sort of have these two very different conversations in D.C. It's called the Tuesday conversation. Tuesday conversation is it's us versus China, and then Iran, Russia, and so forth. And like this revolution is here, and the U.S. needs to be the dominant technology global superpower because that's what's going to lead to us, being strong and protecting democracy and protecting our allies and all these other things. And so, what can you in Silicon Valley do to advance technology as fast as possible? And then on Thursday, I go back, and they forgot about the China topic. Instead, they're just focused on the U.S. and they're like, technology is like weird and scary, and like it's like freaking us out, and like AI is really scary, and like we think we ought to stop this whole thing, and like we need to regulate, and we need to like shut this stuff down, and like can't you people please slow down, right? And then I kind of say, well, like I repeat the Tuesday conversation on Thursday, and I'm like, could you please reconcile these 2 points of view for me? And they say, no, that's your job. So there's a real tension underway right now, and one of the
are those the same people or different people?
So sometimes they're different people. Sometimes they are the same people. It may surprise you to hear that sometimes politicians are not completely consistent from day to day. And look, both of the kind of give the devil his due. Like both of these impulses are very emotional, right? These are very emotional topics, because if you picture us losing a war with China, that's just devastating emotionally. If you picture AI, completely revolutionizing everybody's jobs and changing society, that's also very scary. And so, we as my conclusion is we as an industry are going to exist kind of between these two very, I would say, sort of emotionally valid, kind of impulses where people have a lot of questions and concerns.
You mentioned that technology has become far more political over the past years. What led to that?
Yeah. So look, I think basically, so I start by saying I think it's our fault. So I blame us, and by us I mean myself and my firm and my companies, and I think it's all your fault. Everybody here shares the blame. So look, like a lot of us who kind of grew up, in technology, grew up, engineering. My degree's in computer science. We sort of were like, wow, like we think the stuff that we're working on is like really important, and like we wish the rest of the world would understand how important it is, and now they do, right? Like they didn't for a long time, and now they do. And so I use the metaphor of the dog that caught the bus, right? Which is, the dog chases the bus, never expecting to catch it, and then God forbid, the dog ends up with the tailpipe in its mouth. Like, what does it do with the bus, right? And of course the reality is the bus just keeps on going, and the dog gets dragged down the street. And so that's us, right? We're the dog. And again, it's a consequence of like, okay, we won. Like the stuff that we're doing turns out really matters. It turns out software really matters, AI really matters, microchips really matter, the internet matters. Like these things all matter. And by matter, I mean these things don't just, they don't just matter to us. They matter to everybody. They matter economically. They matter culturally. They matter, socially. The runways, the spectacular runway demos, like, people in Hollywood are like freaked out, right? Because like, what does it mean to be entering a world in which movies can be rendered by AI, right? And what does it mean, for example, I'll give you an example, like, movie actors, like if the great movie actors of the past can have their images, being rendered in AI, for the next 1,000 years, literally is the future of the movie industry going to be Tom Cruise movies for the next 1,000 years, kind of rendered over and over again in AI. Like, will there ever be any new actors, right? Or we'll just all be watching Tom Cruise movies. And technically we're going to be able to do that. And so people in Hollywood are like super freaked out. Lots of people are just getting, I say increasingly upset. There's a longshoreman strike actually that kicked off today. Where the guys, basically people who load and unload boats on docks, and it's like a flat out just anti-tech strike. It's just flat out, no more automation, like we're done. Literally that's the strike, is no more automation, no more machines, we're done.
Do you think there's an angle here where AI levels up the discourse, helps improve the discourse, helps with governance, or is that, further out?
Yeah, look, it does. I mean, one of the things. So look, people see So start by this. One of the great things about AI is it's rolling out in actually a very democratic way, right? So and if you think about this, like the way the computer technology rolled out like 50 years ago, it showed up in the form of like $20 million mainframe computers, and then it trickled its way down over 30 years to personal computers and then smartphones. One of the most amazing things about AI today is the best AI systems are rolling out to consumers first, right? And so ChatGPT and Claude and all these things are rolling out to consumers first. And so, and this is one of the great things about technology is like, and by the way, the usage numbers are like, on fire. And so the number of just ordinary people in regular jobs, in regular professions, who are able to use ChatGPT or any of these systems today and are able to, ask questions and get guidance and figure out how to like deal with complex situations or deal with the government or navigate, laws or, figure out like all of a sudden everybody has like an AI they can talk to kind of help them through all these things. And so I think there's the prospect for sort of a general uplift of intelligence, basically of people having, a level of intelligence available to them at their fingertips that we haven't historically had. That certainly includes, politicians, policymakers, that certainly includes, people like military planners. Like everybody's going to have this sort of additional level. We used to call decision support systems. And so like, there's sort of a chance for everybody to kind of get smarter in a very interesting way. But, I would say that hopefully that means arguments can get a little bit more rational. But what that doesn't do is I don't think that dampens emotion at all, right? And I think there's going to be just tremendous amounts of emotion as this technology rolls out, as is already happening. Yeah. And so I just think like we as an industry are going to have to increasingly step up and explain ourselves and articulate what we're trying to do, and engage in the policy process and in politics, and really help people understand this. And by the way, also make sure that this technology stays democratic and stays open. One of the reasons I think open source is so important is I think it'd be very bad if this technology is centralized in the hands of a handful of companies. I think it's very important societally, culturally, that this is something that everybody has access to. On
the open source topic,
right.
How do you see that playing out? Do you think it could genuinely go in multiple different directions, or there's a, kind of an inevitable outcome here?
Yeah, no, so there's a real fight. So there's a real move underway to ban open source, and specifically open source AI, and specifically the math under AI, which is fairly mind-boggling for me as an engineer. Just in the
talking about linear algebra.
It's not that complicated, right? Like it's right. It's linear algebra. It's gradient descent. These are fairly basic algorithms. They're taught broadly in schools today. My 9-year-old is starting to learn this stuff.
Nice.
There are videos on YouTube that teach you how to do this. There's textbooks.
Yeah.
It's like half the kids at the Stanford freshman class are taking the Intro to AI course. They're learning this stuff. And so, but like there are serious, like the discussions in Washington are like disconcerting on this topic because they seriously, talk about this. And then, there's like outright bans, and then there's also just like sort of what I call sort of the potential for like this sort of stifling blanket of regulation. And the precedent for that is what's happened in the EU, where they have actually done this. They've actually implemented a stifling blanket of regulation, including most recently on AI. And the result is, they've effectively outlawed, to a large extent, they've outlawed technology startups in the EU, and the market has responded. And there's a handful that are really good, but there's not very many. And Europe used to be like amazing. Like half the great tech companies in the world used to be in Europe, and now it's down to a very small number. And so we have this like real life cautionary example of how this can actually go bad. And then we have a fair number of people in the U.S. and in California, which is amazing, who basically want to adopt the EU model. Yeah. And they're lobbying very hard to do that. Some of those people, by the way, are true believers. They really believe that there's like a profound societal threat or existential threat or various other kinds of threats. they really believe it, and you can kind of see it in their eyes. And then, there's a bunch of other people that have commercial self-interest, right? And, they want to establish monopolies or cartels of different kinds, and they want there to be, basically government protection for their business. And so there's this like unholy alliance that's sort of formed up between these two groups.
So there's
and there was a real, we just had this real fight in California.
Yeah, and it's a very important role for policy to play here.
Yeah.
So this is the Ray Summit. This is an AI infrastructure audience, largely. What does this wave mean for people building AI infrastructure, providing those capabilities? What can we learn from previous technological shifts that you've seen?
Yeah. So I mean, look, like it's it's going to be prime time. Like you guys are in the right field because this is it. Like this is going to be the big build out. And it's just starting, and it's going to be one of those things where we look at the stuff that we have today. We look at it, 5 years from now, 10 years ago, and it's going to look like it was, belongs in a museum as compared to what's coming. And so, all of us here are going to play a big role in building that. And so this is going to be like absolutely prime time. There's an unlimited number of technical issues to solve, obviously. But look, on top of that, we're on this incredible voyage of discovery, I think, as an industry and of a world of, which of these domains of AI are going to be the ones that really take the fastest. Just give you this sort of, here's like an amazing question that's playing out right now, which is the whole history of the, kind of AI robotics, kind of field broadly is that everybody assumed for a very long time, including when I was in school, that you would kind of get, you would get the low-level stuff first. And so you would get like robots that like pack your suitcase and like clean your toilet and cook you breakfast first, and then maybe decades later you would get robots that could like compose songs or like draw artwork, right?
Yeah.
And it turns out to be the reverse. It turns out it actually turned to be quite easy to get a robot to like compose a song or like draw artwork. It still can't pack your suitcase.
It turns out math is actually really hard.
Yeah, exactly. Yeah, and especially right the minute you intersect with the real world, things get very complicated. But look, the AI revolution is playing out today is mainly one at these sort of higher levels, things involving basically software information bits. But I think the robotics, revolution is very close. And I'll just give you my favorite example of that. There's this company in China called Unitree, and they make a robot dog. If everybody's seen the demos of the Boston Dynamics kind of robot dogs, but you've probably never seen one in real life. Because they're just too expensive. They're like $50,000 and up. This company in China has $1,600 basically that robot dog.
So do you think
so there's this robot supply chain that's basically forming up in China like really quickly. And drones were kind of an example of that. Where China just like swamped the world with drones, and I think they may well swamp the world with robots, at least on the hardware side. And then there's all these questions around how to actually build all the software for robots, and Elon and others and lots of startups are working on that. And so it may be that we have the sort of bits version of the AI revolution. It may be followed like almost immediately by the atoms version.
That's incredible. So there's a chance that the humanoid rollout will look more like a $20 subscription democratized versus a $20 million mainframe.
Yeah, look. So this company Unitree has they have I think it's a $50,000 humanoid now hardware, and if you just watch on their website, like they're advancing the sort of hardware capabilities like super quickly, and so it looks like the humanoid robots when they roll out, I don't know, mass market.
You're talking about to consumers.
To consumers. Well, the hardware cost looks like it's going to come in at I don't know $20,000, $10,000. Nice. And at that point, you can afford to have a lot of these things, right? And you can afford to have subscription models.
Yeah.
Right, and so I don't know. I'm not positive how fast this happens, but it could actually happen very quickly now.
Yeah.
One of the very funny things right now is these robots. You see the demos, these humanoid robots, they've got their control system, which is like the state of the art. It's like this reinforcement learning algorithm to try to get it to like crack an egg without destroying everything on the table or whatever. But then they've all got like LLM user interfaces with like voice now, and so. It's like struggling to crack an egg, but it's like teaching you quantum physics, right? Like in like a plummy British accent, like at the same time, right? Yeah. And so there's this software kind of wave happening right now to try to like merge those approaches together, right? And have sort of multimodal models that are capable of reasoning and planning, and the new Llama release just dropped I think last week that has multimodal open source. And then OpenAI just released their O1, the reasoning and planning engine, which they say is going to get a lot better from here. And so it may be that in a year we actually have a sort of single multimodal model that can do reasoning and planning that can power a robot, and then we're off to the races.
It's interesting to see how important all the multimodal capabilities are for robotics and real world stuff.
Yeah, and look, then what you're dealing with, then it goes back to the topic of this conference, then what you're dealing, so what made Tesla's self-driving cars work is they put 1 million cars in the road, they gathered all the imagery from all those cars, they used that to do deep learning, and then they made all the cars, really great at driving themselves, and they roll that forward, they compound it. But like, we might be in a world within a few years where we've got 1 billion humanoid robots that are also gathering all that data and feeding it back and getting better. And so it may be one of the largest scale technical systems that we've ever built.
Yeah, that'd be incredible.
It might be very close.
Let's talk a little bit about investing in AI. Yeah. So it's maybe a little too early to say who the eventual big winners in AI will be. Right. Has your perspective on that changed over the last few years?
Yeah, so there's this glorious, amazing difference between running a company and running an investment firm, and I'm gonna really, he's gonna be haunted by this for the next month, what I'm about to say, because he actually has to run one of these companies. When you're running a company, you have to have a strategy, and like, it has to make sense, right? And it has to be like an actual, like, you have to like lay it out, and you have to like have a conference like this. You have to show everybody what the strategy is, and it has to make sense. And if it doesn't make sense, it doesn't reconcile. People get upset. The one saving grace about on the investment side is we don't need one of those, and the reason is because we invest across a portfolio, and so we can invest across basically different approaches, yeah. Right? And so we can invest in infrastructure and apps. We can invest in open source and closed source. We can invest in different technical approaches, and so we kind of fully take advantage of that. So I would say, like, a lot of the questions on the future of like the investing side, a lot of those questions become economic, of like, where's the value going to be, where's the revenue going to be, where's the profit going to be. I'll give you one of the very big questions right now, which is, are the large language models like OpenAI, are those businesses basically a race to monopoly and infinite profits because of scale, right? The biggest company is going to have the best model. It's going to answer all the questions better, and then they're going to charge whatever they want for it. It's going to have super high margins. It'd be the world's best business, and basically, and that's like the track that, like, that's what happened with search, right? Where kind of Google ended up in that position. And the answer is maybe, and then, or the answer is actually, are all those companies actually in a race to the bottom, right? In which it actually turns out, selling, intelligence is like selling rice or something, where it just turns out anybody can make an LLM. There's open source LLMs. There's new LLM startups every day. And it just turns out anybody can go scrape the internet, anybody can buy the GPUs, and then anybody can basically get the same result. There was a famous Google memo that leaked called, we have no moat, and neither does anybody else, where they kind of articulate, basically saying if you have the same data, you get the same results, everybody has the same data. And so in that case, is it a race to the bottom? And by the way, there's some evidence that it's a race to the bottom because the price per token, right, of generated LLM output has dropped 100x in the last year. Yeah. Right, which is like much faster than Moore's law, which is the exact opposite of what you'd expect if somebody was going to, get a lot of profit out of that business. So, maybe that's a race to the bottom, and the term sometimes used there is a profitless prosperity, which is, like selling rice or any commodity. These companies will have a lot of revenue; they'll just have very, very low margins. I think sitting here today, nobody quite knows the answer to that. It also depends on things that happen. In the ecosystem. I think, like, Meta, where I'm on the board, the release of the Llama, I think open source models has really changed how the future is going to unfold. Because having fully competitive open source, I think, really changes things. And so there's really big questions around where the value capture is going to happen, and we're actually trying very hard to not prejudge that, because I think we actually don't know yet.
Makes sense. I mean, the fact that a lot of AI startups need to spend a lot of money on GPUs, right. How does that factor into your investment decisions? Yeah, so that's by the way, the Peter Thiel thing. The Peter Thiel thing is, we're all wasting time with all these software companies, right? We should just put all of our money into NVIDIA, and call it. And by the way, for the last 10 years, that would have been a very good strategy. And so the model there basically is NVIDIA will soak up basically the entirety of all venture capital invested into AI startups, plus all revenue that those startups generate, and they'll just capture the whole thing. And by the way, there's a picture of the world where that actually that's what's happening today, right, for sure. And then there's a version of the world where that happens for many years to come. And that argument basically says NVIDIA is way ahead on the technology for the chips, and then on top of that, they've got all this other technology like CUDA, so they've got this incredibly, kind of strong, kind of technology lock-in. So that's one argument. The other argument, though, is what traditionally has happened in the chip industry is leads like that last for a while, and then they generate a huge profit pool that draws competition, and market forces kick in, and then you have every other chip company in the world, from AMD to Qualcomm to Samsung to the Japanese
companies and everybody else and all the startups, and Cerebras, I think, is going public this week. And so you have lots of startups, and you just have like lots of people who are like, wow, I want a piece of that pie. And by the way, another argument on that would be GPUs. GPUs were not originally developed for AI, they were developed for graphics, right? And if you were developing chips from scratch to just do AI, they might be very different chips. Yeah. By the way, Google has their own chips, Amazon has their own chips.
We're seeing an explosion there.
Explosion of chips, and so it may be in 5 years from now, NVIDIA is still a great company, but they're part of the ecosystem, and it turns out there's 5 other big companies and 10 other startups and a whole bunch of other approaches that make just as much sense. And then again, you might have big revenue growth in the chip industry, but much smaller profits. And so, but again, none of these things. One of the things that's hard to forecast these things is it depends on what people do, right? And so, what decisions are made today at the other big companies, and what decisions are made by the startups and VCs, and by the way, customers and users, and all the people building around this. What do they all want? And so we're kind of on a collective mission of discovery to figure that out.
Maybe to wrap up, for all the future founders and current founders in the audience, do you have advice you'd give them about starting businesses or running their business in today's environment?
Yeah, so I think the big thing on starting a business, I think the big thing is starting a company, the advice is kind of always the same, which is it very rarely makes sense to just say, I want to start a company, therefore I'm going to go in search of an idea. The great companies, at least in tech, usually what happens is they're started by somebody who has been deep in the field of what the startup is doing for probably many years earlier. Before. They're probably very deep domain experts. And by the way, this gets glossed over a lot. A lot of these successful tech companies in the Valley, they kind of have these mythological founding stories where it's like, oh, I was just a little kid and I just had this idea and it all worked. And it's like, well, no, like I was in a lab for 10 years before that, right? Trying to get this stuff to work. I was at school. I worked for a big company. I worked for another startup, and I learned everything. And so most of the successful startups come from people who have spent 5 or 10 or 15 years deep in the trenches, really deeply understanding the nature of a problem and figuring out a better way to solve it. And so look, I think there's like probably a large number of great startups that are going to come just out of this audience in the next decade. In terms of how companies operate in this kind of rapidly changing environment, our big advice always is basically run experiments. There's always this kind of daunting, thing whenever you're sort of responsible for an existing business. I've got all my existing customers, my existing employees. I've made all these commitments. Doing a new thing always feels kind of weird and scary because it's like, what if it doesn't work? And it's going to really break what I have. And so what we always sort of advise is the right way to do that is try to figure out, try to run the smallest possible experiments to kind of try to prove a hypothesis. Take a small number of customers or a small segment of the market and explore. And then, by the way, try to make that a habit inside the company. Try to run lots of experiments like that over time.
Seems like generally a good practice.
What's that?
It seems like generally a great practice.
Yeah, exactly. Yeah, exactly. And basically build option value. Learn as you go. But without having huge downside risk as you run the experiments. And then when you tap the vein and you think you figured it out, that's when you commit the business.
Marc, thank you so much. Really appreciate all of your insights.
Good. Awesome. Thank you, everybody.
Thank you.
Thank you.
All right.
Thanks, folks.